see anything that looks bad on here. Woo! Wow. That's the second one. That's really bad. So, in my experience, if you have voltage on one of these capacitors after you pull it out of the circuit, which that's only the second time I've ever seen that happen, but it's my experience, if you have voltage on your capacitor for your pump or whatever you're working with, whatever motor you're working with, it means that there's an open winding in the pump itself. So that's really bad. When there's an open winding, it's not able to like self-discharge. So I don't know if you guys saw that spark. It keeps bringing up a little more potential. People say you should use like a bleed resistor, but nobody carries bleed resistors with them. Or at least I don't. 85 microfarads. Let's see what the rating is on this. 86 to 103, so it's technically a tiny bit out of tolerance, but not much. We'll check it one more time here. Yeah, this time it's 90, so we will try, in case the relay is actually the issue, we will try slapping a different control in there. It's a 3/4 horsepower, 230 volt. You guys want to just make sure that your terminals are the same as the existing. L1, L2, R, Y, B. Of course, we do have power still on to this thing. I don't know where the breaker panel is. Made a little bit of noise. See our pressure switch? I already had checked it before, but we'll just check that again. Volts alternating current from one side to the other side. You can see we're getting a solid 248 volts. But even with that new pump control slapped in there, we're not getting anything. So, pop this back out. Now, this also does not have any bleed resistor. Oh, actually this one does. Okay. If you look inside there, there's a little bleed resistor installed on the capacitor. So this is a little bit safer because it's going to automatically discharge no matter what happens. So this one, well, we don't have to snap it or check it. I mean, you would still want to check it before you test it. Last thing we'll check down here is this pressure tank, see what pressure we're at. Looks like we're at about 35 psi. So, you're supposed to be 2 psi lower than your cutout pressure. I think this one's a 3050. So technically it's a little on the high side, but that gauge isn't necessarily the most accurate probably, so this one is a 3050. So technically the pressure in the tank's a little bit high. It's been that way since 2012, so I think we're actually just going to leave it in case it's my gauge. But pressure tank's good. This seems to be good. Pressure switch is good. Everything's good here, so we just have to go outside and find the well head and see if one of the wires got burnt off or something out there. This thing is so rusty. I don't know if I'm going to be able to get into this housing. How rusty it is. Oh, I got it to turn actually. It looks like this well's been leaking water around the head, which I've never seen before. Oh my. This is crazy. Look at this. So yeah, it did have water. The pipe broke off down below in the well, and it was just pumping water up around the casing head. I think that is bare copper. Let's see if that's got power on it yet. This is crazy. Yeah, these are just bare conductors. That's terrifying. So, yep. They're gonna have to have the well guy come and deal with this. I'm sure it wrecked the well. The well just ran continuous for probably like months, or probably like a month. I mean, you can see that they had water running down this. So maybe, I don't know, probably could do that in just a week with how much iron's in this water, but where the copper comes out of those, goes into those, that's all just melted together, and this is just full of water. That is just terrifying. So we're just gonna carefully stick the lid back on and tell them they got to get the well guy to come look at it.